So we were in section 3.4, partial fractions, and the last thing that we did was we looked at repeated roots. And in repeated roots, we have x cubed minus 2x squared in the denominator. We factored it, found out that our roots were 0 and 2. And so when we went to solve for the variables, we unfortunately were short. So we had to create or choose a value. And then the last example I gave you was this one, x equals, let me see here, x cubed minus 2x plus 1 over x minus 1 cubed. And in this one, we had three repeated, we had yes, we had the repeated root x of 1 3 times. And so with the repeated root of 1 3 times, we only have one root of 0 and the root of 1, but we have four variables to solve for A, B, C, and D. And so therefore, what we ended up doing was I told you to choose two other parameters. So choose maybe x equal to -1 and x equal to 2. And then when you do that, you should have been able to solve for everything. Okay, so for that example, trying to find the solution here. Yep, here it is. So, oh, nope, that's not it. Oh, yes, it is. Okay. So here it is. So the solution to that example turns out to be that this integral copy okay, so this integral actually equals negative log of the absolute value of x plus 2 times the log of the absolute value of x minus 1 minus 1 over x minus 1 plus a constant. Okay, so the only last thing to do on this is irreducible factors. And so irreducible factors, those are the most difficult ones. And that is because you have something that is a quadratic, but it does not factor. So here's an example of an irreducible factor. So what do I mean by that? So let's look at this example. So here in problem 5, you see that we have x minus 3, that's a linear factor, but I have a quadratic x squared plus 4. If that was x squared minus 4, then I could factor it into x minus 2 times x plus 2, and I would have, once again, all linear factors, but I can't. So when you have an irreducible factor, that means I'm going to still take x cubed minus x plus 2 divided by x minus 3 times x squared plus 4. And the linear factor a still goes over x minus 3. But because I have a quadratic irreducible factor x squared plus 4, I have to put bx plus c over top of it. Okay, so anytime you have an irreducible factor, you have to use a linear factor on the top, bx plus c. And so now when I go to solve for my major equation, I get x cubed minus x plus 2 is going to be a times x squared plus 4 plus bx plus c times x minus 3. And as you can see, the only root that I have for this problem is x equals 3. So I have A to solve for, B to solve for, and C to solve for, but I only have one root. So that means I'm going to have to choose two other numbers in order to solve for the other two parameters. Okay.
Professor Locke,
Yes.
x3, you did x3, it's supposed to be x2. Like the original equation says x squared.
I'm sorry, I don't see it.
Like original equation says x2 minus x plus 2. And then you rewrite the equation as x3 minus x plus 2.
Are you talking about the last problem?
No. I'm still on this one.
It is x squared minus x plus 2 in the numerator. Right?
Yeah, but in the original problem, this is x2. Do we change it?
I'm not sure what you're talking about and what original problem.
And you
It's a-
stop where you started, right? And you put x cubed minus x plus 2 over.
Oh, X, I understand
Thanks.
now. Okay. Woo, I didn't know what y'all were talking about. Okay, it is supposed to be x squared. You are correct. Okay, thank you. Oh, I kept looking at, see, I couldn't see it. Thank you, thank you, thank you. Okay. All right, any questions? All right, so we found the major equation. And that's good for us. So now we want to let x equal to 3. So x equals 3, we get 3 squared, that's 9, minus 3 plus 2. And on this side, I'm going to get a. 3 squared is 9 plus 4. And then when I put in x equals 3, that gives me nothing. So that's gone. Okay, so 6 plus 2 is 8. And then this is 13a. So a is 8 over 13. Okay, so now I need to solve for B and C. I may as well use x equals 0. That'll be nice. And I'll try x equals 1. So let's let x equal 0. And if x equals 0, I get 2 on the left side is equal to 4a plus, I'm going to get c times -3. Any questions about that? Okay, because I put in x equals 0, so the b drops out. So I get 2 is equal to 4a plus c times -3. All right, so this is -3c is equal to 2 minus 4a, and a is 8 over 13. Any questions about that? Okay, so I get -3c is going to be 26 minus 32 over 13. That's common denominator, which is just 6, -6 over 13. All righty, so now I can find c. So c is going to be -6 over 13 divided by -3, so that's going to be 2 over 13. So now I found c. Okay. Next, I need to find b. So let's let x equal to 1. I guess that's probably the best thing I could do. All right, and if x is equal to 1, I need to be able to see my major equation. I get 1 minus 1, so that's 0. So I get 2 is equal to, x is 1, so I'm going to get 5a plus b plus c and then I'm going to have times -2. Okay, so now I'm solving for b. So I have 2. Over here, I have -2c, so I'm going to get minus 5a. And then I'm going to have a -2c, which is going to move to the other side as a positive 2c. And that's going to give me a -2b. Okay. So I already know the denominator is 13. So I'm going to have 26 over 13 minus 5. What's a? A is 8 over 13. I'm writing 8 over 30. Plus 2, and c is 2 over 13 is equal to -2b. So I get 26 minus 40 plus 4 over 13 is -2b. So that's 30 minus 40, so that's -10. So b is equal to 5 over 13. Okay, so provided that I did that correctly in such a hurry, we end up with the original integral actually, yeah. It's going to be the integral. Now the first term is a, and if I remember, a was 8 over 13. And that was divided by x minus 3. Plus bx, so that's going to be 5 over 13 x plus c, which was 2 over 13, all over x squared plus 4 dx. So let's pull out the 1 over 13. Let's get rid of that. Okay, and so we're going to get, this one is going to be 8 times the natural log of the absolute value of x minus 3. So that part is done, but we now have 5 times the integral of x over x squared plus 4 dx. And we still have left 2 times the integral of 1 over x squared plus 4 dx. So we break the last 2 terms up. All right, so we break it up so that we have this integral, and then we have this integral. So let's break it up. Okay, so that becomes 1 over 13 I'm going to get 8 times the natural log of the absolute value of x minus 3. Plus, this is going to give me 5/2 the natural log of x squared plus 4. And this is going to give me 2 times, well, look, something we haven't seen in a bit. The tan inverse, I forgot my 1/a. 2 times 1/2, 1/a, the tan inverse of x/a. And that whole thing all done plus a constant. Okay, any questions about that? Any questions? So for every irreducible factor, for every one, you must have a bx plus c. If you had another, let's say x squared plus 9 in the denominator, I would have a df plus e over top of it. So each time you have an irreducible factor, okay? All right, so let's say so this is the last example. We're not going to solve this because this is going to be pretty hideous. But let's say I had the integral and this is over x squared times x minus 3 times x squared plus 4. Let's make this 2x to the 4th times x squared plus 9. Okay, dx. Now, granted, I would never give any student this problem to do, but it would have to be well, you guys write what you think it would be before I tell you. I want you to write what you think it would be. We're not going to solve it because we'd be forever solving it, but you tell me what you think this would be. So please write that down. Okay, anybody have an answer? I didn't ask you for the major equation. I just want to know how you separated it into partial fractions. Anybody have an answer?
I think I have one.
Okay, Peyton, what you got?
It will be a over x2.
Okay, you got to have a over x first.
Okay, and then b over x plus b over x.
B over x squared. There you go. Okay, keep going.
Plus c over x minus 3.
Okay.
And then dx e over x2 plus 4.
Okay.
And then fx plus g over x2 plus 9.
Excellent, excellent, excellent. Okay, that's what it would be. Okay, so that is the end of that.